In Chapter 9, we're going to be talking about rational expressions and rational equations. Now, a rational expression is just the ratio of two polynomials. So, similar to a fraction, whereas a fraction would just be one number over another, so like 1 over 5. A rational expression, we would say something like x plus 1, so a binomial, over x plus 3. So one binomial over another. So anytime we have a ratio of two polynomials, one over the other, that's considered a rational expression. So in 9.1, we're going to be talking about multiplying and dividing these rational expressions. Before we go on to that, we're going to talk about just how to simplify them first. And kind of ease into that, we're going to talk about simplifying just normal fractions. So if we had the fraction 12/8, we would notice that we could take out 2 from both of those, in which case we'd be left with 6 over 4. Looks like we're almost done here, except we can take 2 out of that again, and we'd be left with 3 over 2. So in the end, we would simplify 12/8 down to 3/2. Now, a good way to check that, or a good way to speed that process up, is to say that 12 is the same as going down to its prime factorization, 2 times 2 times 3. And 8 equals 2 times 2 times 2. So if we put 12 over 8, now we can just cross out or divide out anything that we see doubling up. So a 2 and a 2, another 2 and a 2, and we're just left with 3 over 2, or 3/2. So we only cross out the common factors that we can simplify throughout. So let's see how this simplifying works with a rational expression. So in this case, our rational expression is 3y times y plus 7 over y plus 7 times y squared minus 9. Now, first thing to do on these is always check, is this factored as much as we can? And actually, we can factor this one a little bit further. We can keep our 3y and y plus 7. And remember, each of these, the 3y and the y plus 7, those are each terms in and of themselves. One is a monomial, one is a binomial. So those are considered two separate numbers. And then the factors down here are y plus 7, and we notice that this is a difference of squares. So we would call this y plus 3, y minus 3. Now we're down into the lowest factors that we can get. Now from here, we just cross out all the factors that double up. So y plus 7 and y plus 7, which means that we've now got the simplest form of it, 3 plus y over, or 3 times y, 3y, y plus 3, y minus 3. So this is the most simplified version of our rational expression that we can get. So then we're asked, under what conditions is this expression undefined? Remember, undefined means when our denominator is going to be 0. So what is going to make this piece down here 0? Well, even though we crossed out the 7s, we still have to make sure that we include those y plus 7s. So if we're taking these three numbers here and just multiplying them together, then to get 0 as our denominator, any one of them would just have to equal 0. So what would y have to be to make this y plus 7 equal 0? Well, we'd say y cannot equal, in one case, -7, because that would give us a 0 there. In this case, y cannot equal -3, because again, that would throw everything off, make it 0, so our denominator would be undefined. In this case, we would say y cannot be 3. So y cannot be -7, -3, or +3. Those are the values in which the expression would be undefined. Let's try again here. We are asked to simplify another expression here. Now, again, remember, these are each binomial. So it's this binomial and this binomial. We can't just say, oh, look, there's a 2 and a 2, and we'll cross those out. That doesn't work because these are each separate numbers. One on the top, one on the bottom. It's not 2 on top and 2 on bottom. So first thing to do is factor out from each of these binomials. So what we can factor out of the top one here, our numerator, is this a to the fourth, which leaves us on the inside here with b minus 2. So that's the factored form of our numerator. What can we factor out of the bottom binomial? We can factor out our a to the third power, which again would leave a 2 minus b. Okay, now things to cancel. If we have an a to the fourth and a to the third, we could write it out as a or divided by a times a, and then cross them out individually, and notice that we have one left. Or, remember our rules of dividing powers of things. If we have 4 on top and 3 on the bottom, we can get rid of the 3, just subtract it from the 4, so we'd have a to the 1, or just a. Now, as well, we can notice that this factor, our b minus 2, and this one are very similar. In fact, it's just the two numbers kind of flipped around. So if we were to take a negative 1 out of the bottom, so pull a factor of negative 1 out, that would leave us with negative 2 plus b on the bottom. And again, because of the commutative property of addition, we can switch those two around even, and we'll call it positive b, and we're adding b, minus 2. And then on top, we still have our a times b minus 2. So now these are our factors that we're working with. And again, from here we can notice we have a b minus 2 and a b minus 2 that we can take out. So we're just left with a over negative 1, which in the end is negative a. So we'd say our most simplified version of this expression comes out to just negative a. And we'll try it one more time here. I'm going to go kind of fast on this one because this is going to be very similar to what we did before. Factor out the top, factor out the bottom, take out any factors that we can. So we have x to the fourth over x to the third, just leaves x on top. Then 3 minus y, y minus 3. Pull the negative 1 out of this one, so negative and plus. Commutative property means we can flip these two around. So positive y, negative 3. Cross out these factors. We're left with x over negative 1. So negative x is our most simplified version of this expression.